So hello friends, welcome back to my YouTube channel. Today I am back with an interesting question. So in this question, a square ABCD is given and its side length is 4 units. We have two circles. One circle is inscribed inside this square ABCD and there is another circle which is circumscribing this square ABCD. In the question, we are asked to find the ratio of the areas of the bigger circle and the smaller circle. So, in the figure, let us draw OD. OD is the radius capital R of the bigger circle. And likewise, let us drop a perpendicular here. This is the perpendicular because if we, with respect to the smaller circle, CD will act as the tangent. So from the center of the smaller circle, if we drop a line segment like this will be 90 degree. Now the area of bigger circle is pi times capital R square. Likewise, area of smaller circle will be pi times small r square. This pi will get cancelled and we will be left with ratio of the radius and that too squared. So our aim should be to find capital R upon small r. So for that, first of all, if we see points D and B, it will be the diagonal of this square and it will pass through the center of this concentric circles. Also, ABCD being square, this angle C will be 90 degree. So now let us focus in triangle BCD. This is a right angle triangle at C. So we will apply Pythagoras theorem here. So BD square will be equal to CD square plus BC square. CD square plus BC square. BD is twice the radius, twice the capital R. So we can write twice capital R whole square is equal to CD is 4 units, BC is also 4 units because it is the side of the square. Each side of the square is same. So 4 square is 16 and plus 16 is 32 and this will be 4 capital R square. So capital R square will be 32 over 4, that is 8. So R will be square root of 8. Now we know the value of R. We can even write capital R is equal to 2 root 2. But right now I am leaving it as it is. This is the value of capital R. Now we want to find the value of small r. For that, let me name this point as point M. So let us focus in triangle OMD. So in triangle OMD, again we will apply Pythagoras theorem here. So capital R square being the hypotenuse will be equal to dm square plus small r square. Capital R is already known to us, that is square root of 8 whole square. Dm, what will be the length of dm? So if we consider the larger circle, CD will be a chord of this larger circle. O will be the center of this larger circle. If we drop a perpendicular on this chord CD, then this line segment OM will bisect this chord. So this will be 2 units and DM will also be 2 units. We can write 2 square plus small r square. So 8 is equal to 4 plus r square. r square is equal to 4. So r is equal to square root of 4, that is 2. Now we can substitute the values of capital R and small r. Okay, capital R is root 8 and this is 2 whole square. So this will be 8 over 4, that is 2. So we have found the ratio of areas of the bigger circle and the area of the smaller circle as 2. So this is the final answer. If you like this video, do subscribe to my channel. See you in the next video.